The galaxy may be littered with alien micromechanes, astrophysicist says. October 17, 2019. Below is an article showing the conventional science optics of how the detection of intelligent extraterrestrial life could be done by looking for alien micromechanes. The galaxy may be littered with alien micromechanes, astrophysicist says. Were micromechane alien probes traveling through our galaxy? It has long been a tacit principle of astrobiology that, in the absence of confirmed alien technologies, some must be imagined. This is far from a frivolous pursuit. Rather, it is an attempt to solve one of the most disconcerting aspects of human existence, usually summarized in Fermi's paradox. In 1950, the famous nuclear physicist Enrico Fermi made an interesting point. Given the size and age of the Milky Way, he said, any alien civilization a little smarter than humanity should have had enough time to explore and colonize it all. Why, then, with the obvious exception of a few dozen people, has no one ever seen evidence of this? Scanning the skies for sounds from extraterrestrial radio broadcasts, the basis of the long-standing extraterrestrial intelligence search SETI project, has so far come to nothing. Other avenues of research, at least since Fermi's implicit challenge, have focused on the search for technological evidence. If the ET is out there, the logic is, he or she must have somehow gotten to where there is, and must be somehow surviving, and for these things to happen, some kind of alien machinery must be involved. All that needs to be done, therefore, is to find a way to detect technology, which is not easy when the object of any such research is completely unknown. This led to some not entirely fanciful imaginations. Flying saucers were an early example, although, despite attempts to build them here on Earth, the engineering challenges inherent in the project seem fatal. Dyson spheres have been and remain a much stronger candidate. Named after the man who thought of them in 1960, the English mathematician and physicist Freeman Dyson, these mega-kit pieces comprise huge energy-absorbing panels placed around entire stars. According to theory, each sphere could capture, convert, and transmit enough energy to power a distant galactic empire. Over the past 2 years, speculation has increased that a real Dyson alien sphere had been located. Such a thing, astronomers suggested in 2015, would explain the eccentric light variations observed in a star rated KIC 8,462,852, but better known as the Tabby star. The latest research, unfortunately for enthusiasts, suggests that the sudden and uneven darkening of KIC 8,462,852 is probably caused by an exolua, Akka planet, disrupting its brightness. Hope, however, is eternal for extraterrestrial technology hunters, and the other most favored hypothetical example is known as von Neumann probes, named after a mathematician named John von Neumann, who came up with the idea. These hypothetical machines overcome one of the main objections to Fermi's paradox, which supposes that ETs would really want to physically colonize the galaxy. Von Neumann's probes allow aliens to explore vast distances while staying at home. Essentially, they are self-replicating devices that erase themselves and then make copies of themselves, rapidly increasing, in fact, exponentially, the number and range. In terms of Fermi's notion, however, von Neumann's probes simply kick the can later. The idea may explain why officially humans have never seen an alien, but it fails to explain why they have never seen an alien machine. Tell that to U.S. Navy airmen to see what they say. Objections to the probe idea come in many forms. Machines would need materials to build their replicas, some researchers note, and there may simply not be well-positioned asteroids or enough rocky planets to allow this to happen quite often. Others cite the theory of evolution. As probes make copies of the codes required for operation, errors are likely to occur. Thus, some probes can become predators, hunting and destroying others, or perhaps at some point, the accumulated errors make most of them dysfunctional. However, recently the idea has been changed. In an article featured on the Arxiv Press website, astrophysicist Zaza Osmanov of the Free University of Tbilisi, Georgia, suggests that theorists are thinking of von Neumann probes on the entirely wrong scale. Using some very detailed calculations, Osmanov concludes that the probe idea works best if the machines are microscopic micromechanes about 1 nanometer long. At this size, he notes, they would not need the substantial resources of rocky planets to reproduce, but they could bind using hydrogen atoms spinning in interstellar dust. He estimates that this is totally more efficient and much faster, with aftershocks occurring in a matter of a few years rather than the longer time scales deemed necessary for macro-scale machines. In addition, the nano von Neumanns would become numerous very quickly, at least on the galactic timescales. Osmanov estimates that by the time the descendants of an initial population of 100 people had traveled a parsec, about 4 light-years, the probes would reach approximately 100,000 or 1x1033. And this kind of micromotor mega-swarm, he suggests, can make them visible only if someone is looking in the right direction. Micromechanes, he says, finding and collecting protons would produce light emissions. Each individual emission would be tiny, but collectively would add something observable, since the mature swarm of von Neumann probes, assuming they are in a level formation and comprising a wave at their leading edge, would collectively have the typical mass of a comet with a length scale of several kilometers. At least in the infrared part of the spectrum, Osmanov calculates, this is a target worth looking for. He concluded, all of the above results indicate that if someone detects a foreign object with extremely high brightness increases, it may be a good sign to place the object on the list of extraterrestrial candidates for the von Neumann probe.